Can you hear me? Yep. Is that on? Okay. Okay, I think it's 4:30. This is data management in Microsoft HDInsight. My name is Andrew Conrad. I'm an engineer on the HDInsight team. Before I start here, how many people have heard of HDInsight? You feel like you know a lot about it, or does anybody think they're an expert? Okay. How many people have heard of Hadoop? I assume everybody that's heard of HDInsight has heard of Hadoop. Okay. And I assume everybody's heard of big data in one way or another. Okay. Just because it's so new, I know this is a 300-level talk, but I'm going to spend the first kind of 20 minutes kind of just giving an introduction to Hadoop and HDInsight. Also, just because there's so few of you, you were brave to stay till Friday afternoon. I don't mind if you ask questions in the middle of the talk, just raise your hand. If it's something that's really long answer, I might wait till the end to answer it, but feel free, we can make it as interactive as people want. So here kind of the agenda. Like I talked about, I'll spend about 20 minutes just talking about Hadoop and HDInsight. And then I'll spend the second half kind of talking about how you work with data, how you manage data with HDInsight. And then the last part, we'll talk about how you consume it, and we'll give some examples of that. So what is big data exactly? This is an interesting topic. Everybody has totally different opinions about this. To kind of get an overall umbrella definition, I went out to Wikipedia, and I came up with this, and I'll actually read this. Big data is a collection of data sets so large and so complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. The challenges include capture, curation, storage, search, sharing, transfer, analysis, and visualization. Now, I highlighted the things that I'm really going to emphasize in this talk is storage, sharing, and transfer. But of course, the other problems are problems that we're looking at Microsoft with our Hadoop products. So let's take a different tack here to think about what big data is about. I like to tell people, let's go over here. I like to tell people about big data with examples. To me, big data is any data that you can't really use in your relational database. It's either too big, or it's in a weird format, or there's too many files. It's just not either realistic from a size standpoint to use your relational database, and more importantly, from a cost basis. And that's why a lot of these big data solutions have sprung up. Now here, this is, was anybody at the foundation talk when I demoed earlier? Okay, so you've seen this before, but the rest of you haven't. Whoops. Somehow we have PowerPoint up here still. Let's get out. That's a little better. So I was talking about something, you guys were all looking at PowerPoint. I apologize for that. So this is a JSON feed that I downloaded from Twitter. And I wanted to get some information about my company, what people were saying about it. This ended up being just gigabytes of data. It's semi-structured. It's real jagged. It's JSON, right? This isn't something that I could like go ahead and start querying and doing kind of BI type data analysis on it. So that's one example of a kind of a big data, the type of data that you see in big data. Now, we can even go worse. So this is another JSON feed that I downloaded from Nike, and this keeps track. I wear one of these little wearable technology which keeps track of how much I move and stuff. So this collects literally tens of thousands of rows a day, just based, it's probably only interesting to me, but you can imagine if you did it over a wide population of people, you get a huge amount of data. The other thing that's interesting here is not only is it semi-structured in JSON, we even start to see things like arrays here. And so it starts to be, when you think about it, this would be really hard to get into a relational database and query with relational tools. But this kind of stuff is very easy for technologies like Hadoop. A couple more examples that probably aren't so obvious. Well, this is the kind of the one that's really obvious, the Hadoop kind of basic use case. This is logs from my application. We're going to do a bit more with this throughout the talk. But this is just like IIS or Windows. It just generates hundreds of thousands, millions of rows of logs or log entries. And these logs just keep piling up, piling up, piling up. But there's a bunch of really valuable information in there that people want to data mine. And just because of the sheer size and the number of files, it's just not realistic to use a relational database. Finally, and this is probably not so obvious, but I downloaded the HTML file for the content catalog for TechEd here. Somewhere down in here is a table of the courses or the talks. And so that definitely could be something that I'd want to mine. Now, in this case, the individual files aren't that big, but if you imagine if I was scraping HTML off like hundreds or thousands of websites, there would be millions of files. And again, that starts to get really complicated when you're working with a relational database. Also, like the JSON, it's not in a format that I can easily get into my relational database. So another example of big data, the key there is it's a lot of files. It's not big files, but a lot of files. So let's try this slide again. So why is big data happening right now? There's really a whole bunch of different reasons. And some of the most obvious ones, storage has become very, very cheap. It is cheaper just to keep all your data and figure out what kind of questions you want to ask later than to try to figure out what to delete, what to archive. You just throw it, especially with cloud-based storage, it's becoming so economical never to delete anything. There's starting to be really large volumes of data. Anything with an RFID, just generates huge amounts of data. Manufacturing's generating data. All these social websites are generating data. There's starting to be a lot more data types. Every little service has their own data feed. Everything generating data has a different source of data. I think, and the user expectations are starting to go up. It's funny. Microsoft and some other vendors have done a really good job with BI in the enterprise. That people's expectations are they want to get answers quickly and easily, and that really has changed the game. Finally, there's real-time data creation. Like I said, like anything like this device or any kind of thing, like all our mobile devices, they're just constantly generating data. And then we just have in our life multiple data sources now. It's not the traditional relational database. We have our phone, we have our laptop, all sorts of different sources. So there's a whole bunch of different reasons that all this data is getting generated and people want to do stuff with it. So HDInsight. So let's start out. So Hadoop, I'll even start out ahead of this, or farther back in time from this. There was a project at Google called Bigtable. Is anybody aware of this? Okay, a few people. Bigtable is basically how Google runs their search business. What it was is they came up with a way to store and index, the internet, and they did it by backing the system with commodity hardware, the type of stuff you can just go to your computer store and buy. So they have millions of these like $500 machines. And the whole idea is that you can do stuff in parallel, and you may get failures, but it doesn't matter because if a few machines fail, you just replace them with cheap machines. And this approach is a lot different than kind of the rack-based relational database approach that's quite common right now. So Google wrote this paper called Bigtable. You can go look it up. What happened then is a group from Yahoo took the paper and they implemented it in a project that they called Hadoop. That's part of the Apache Foundation. And then there's also a bunch of other projects that I'll talk about that kind of, when you say Hadoop, we call it the Hadoop family of applications. And then what this is open source and it started to get released. The Hadoop distribution is free. You can download it, you can install it. There's no license on use. So it's a completely open Apache open source project. Now, at Microsoft, we have a project called HDInsight. And we have a partnership with one of the companies that has a large amount of the Hadoop contributors. And I'll talk more about that in a second. But what we do is we want to build up kind of the ecosystem around Hadoop. So we work with our partners, and we're actually part of the open source effort with the core Hadoop project. We just got our first contributor the other day. They were nominated and approved. And a lot of what we're doing is we're taking the Hadoop code base and making it so it runs on Windows. It was originally developed for Linux, and then so obviously we have an interest in making it run on Windows. But then again, we are also putting improvements in that are general improvements. There's a project called Stinger. Hadoop, anything in Apache has a lot of open source, they call them incubator projects, and one of them is called Stinger that's meant to make querying faster. It's not really important for this talk, but the idea is that Microsoft is driving and contributing to that project, and we're putting it in the Apache open source Hadoop project. Now, Hadoop has been around for about 7 years. It's continued to evolve. It's coming up. It's pretty stable, and some of it's on like version 1.2, 1.3, and they're headed towards a 2.0 release. There's all sorts of companies that are using it. Some of the big ones are like Facebook, obviously Yahoo, Amazon, and then there are a number of companies now starting to offer it. Now, our offering is called HDInsight, and what it is we take Hadoop and we host it as a service in Azure, and then we're building a bunch of tooling around it, like being able to work with Excel, being able to work with analysis service, all of our kind of BI tools that hang off it. And the idea, and I'm going to talk a lot more about this, is but you get your big data into Hadoop, you refine it, and then you're going to put it back into, once it gets to be a size and a shape that you can work with realistically, then you bring it back into your standard kind of BI workflow. Whoa. We okay now? Okay, I'll try that again. I apologize for that. So here's this is a basic architectural diagram of HDInsight. I'm going to start rattling off a lot of Hadoop project names. There's a couple that I really want you guys to get to know and understand in this talk. The rest of them, don't worry about it. Hadoop is a very, very nice kind of opt-in. You can opt into little pieces of it at a time. It might feel very overwhelming at first. I believe in Hadoop it's made up of 10 to 12 applications that are the main ones, and then a whole bunch of incubator projects. But you don't need to know all of them. It's not important. I'll tell you the main ones you really need to learn. So Hadoop has two big pieces at its core. One is this distributed file system called HDFS. And that is down here at the bottom. This is just a like I was talking about, this is based on the Google Big Table idea, and this is just that with commodity hardware, this is a distributed file system. It has redundancy completely built in, so if any node fails, it just takes care and repairs itself. And it's really good at handling large amounts and big files. That's what it's been tuned for. On top of that is kind of the main execution environment called MapReduce. And this is currently written in Java. A lot of that is changing, but what MapReduce is it's a way of writing programs or queries, and in the Hadoop world we call them jobs. But what you do is you do a map phase and a reduce phase. The map phase does a transformation. The reduce phase, or the reduce phase does the aggregation. And this is all scans over your data. So if you had 1 million rows and you wanted to just find a few rows, it scans everything. So it's really made to scan over the entire contents. And like it's not your traditional SQL queries, it's more like batch queries, the kind of jobs you would run. Now, on top of MapReduce, there's a couple of very popular Hadoop applications. One's called Hive and one's called Pig. These are both data warehousing applications. I'm going to show you a bunch with Hive. Hive's probably the easiest one for people with a SQL background to get into. Pig is more for like ETL type processes, but it can be used also to do kind of data warehouse stuff. Then there's also a component called hcatalog. Now, the key to hcatalog is this is where Hadoop keeps track of the metadata. So in HDFS, in the file system, it's just a collection of files. It's not like SQL. And the key here is the data is stored in the file in your format, however you want to store it. And the metadata in HCatalog tells Hadoop how to interpret those files. So if you think about a relational database, when you load data into a relational database, the relational database takes that data and puts it into the structure that's optimal for that database. But Hadoop is designed to be flexible. Remember, we talked about a whole bunch of variety of different data types. So you can put almost any text you want into Hadoop, and as long as Hadoop has the proper mapping in HCatalog, it can work with the files. So there's a couple other interesting tools. One is called Scoop, and this is used for data movement. This is basically a tool that transfers data into relational databases from Hadoop and then from relational databases back into Hadoop. So it's kind of like a BCP type tool. There's also a workflow engine when you want to do multiple jobs with some conditional logic or some more advanced workflow features. That's called Uzi. And finally, there's another project called Ambari. And this is kind of the monitoring interfaces for Hadoop. And this is where it does both admin and monitoring functionality. So if you take this collection of projects here, this is really the main family of projects that make up most of Hadoop, or the stable part of Hadoop right now. Now, there's one thing. So I told you all about HDFS, but now I'm going to switch it up a little bit on you. One of the features of Hadoop is that if you have your own storage, that you can build an implementation of HDFS and plug it into Hadoop. And what we've done in Azure when we host Hadoop is we have actually taken the Azure Blob Storage. Is everybody aware of Azure Blob Storage? Is there anybody that isn't? Okay. So this is actually our storage for Hadoop. And what we've done is we've implemented a number of interfaces so we look like HDFS to Hadoop. So I'm going to talk a lot more about that. But in general, this makes your life it really simplifies your life. So here's a little bit more about Hadoop. The way Hadoop works is there's a head node, and if you think of these nodes are basically machines. And I'll show, and when you have a set of machines, it's a cluster. And I will show a cluster in a little bit. But what you have in Hadoop is you have one head node, and then you have a number of compute nodes. And the idea is that the data is on the compute nodes, and the program is sent to the compute node. And so you keep from having to move a bunch of data across your network, which would become a bottleneck. And then on top of that, there's a set of REST APIs. And then what we've implemented is some of the things I'm going to demo today is that we have a dashboard on top of that, so you can work with it in a graphical environment. Now, as I said, normally in Hadoop, your compute nodes are also your HDFS file system, so the data is on the same machine as where the work happens. In our case, it's not, because the data is actually stored in Azure Blob Storage, and it's not copied onto the cluster. So you're probably wondering how we get away with this. So I want to jump ahead a little bit, and I'll come back. Storing data in HDInsight, as I said, we store everything in blob storage. Now, let's jump all the way down to the how. This is really the interesting thing. We implement this thing. Now, in our data centers, as long as your storage account is in the same data center as your Hadoop cluster, we use a system called flat networking. And we actually see better performance over the network in the data center than we do going to disk. So this Azure Blob Storage is actually faster than if you stored it on disk. Now, the other part, which the users will like, is it's significantly cheaper too. You can store the data in Azure Blob Store from a fraction of what you could store it on a Windows virtual machine. Now, the other really cool feature that this enables is this is a little bit different than a traditional database server because your data is persistent, but the compute doesn't have to be. So you can have your data sitting there, and when you decide to query it, you can fire up a cluster. The cluster will do all the work, give you the answer, and then that answer is written back to the blob store. And then as soon as you're done with the cluster, you can tear it down and never see it again. In fact, if we are in the middle of doing a job and we see some problem with the cluster, we'll actually tear down the cluster and restart the job for you with a new cluster. And you don't even necessarily know it. So the cluster really just becomes pure compute power. It's completely transient, and there's no state. And it makes a real nice model. So let's get a demo. I've done far too much talking, so let's go let's go do a demo real quick. I'm going to show you how to create a Hadoop cluster, and then we're just going to look at the file system a little bit. So this, we are in preview right now, and it's been a little bit iffy with creating clusters the last couple days, so we'll see how we do here, but just giving the warning ahead of time. So this is the Azure portal. How many people have Azure, have Azure memberships right now, or have gone and played with it? Okay, a few. So one thing you want to do, if you've never done it, the easiest way, we have this page, Microsoft.com/big data. You can go up here, and it talks a bunch about big data. It actually tells you what big data is. But then you click on this Sign Up for HDInsight service. Now, this is a little bit confusing, but what happens is you go then to this Azure page, and you click Free Trial if you haven't tried it before. Now, what you can do is you can go up. This is completely free, and you can do 1 month, and then you can use any of the services, including HDInsight, for free for 1 month. So if you haven't, there's no reason not to try it out if you haven't. Now, what you do is once you get an Azure login, you come into the Azure portal, which is this right here. And you can see on the side here they have, like, I can get a SQL database, I can get storage, I can do mobile services, a number of the different technologies we've been talking about at the conference. Now, what I'm going to do is I'm going to create a cluster. Now, the first thing I need to do, as I told you earlier, we have to have a storage account, more specifically blob storage, so I can create the cluster for that. So the first thing we're going to do is create a storage account. I'm just going to say new, quick create. Anytime there's a quick create, that means it's very easy, and all you need is a single screen to get the information you need. Just going to call this TechEd. Let's go 999. And this little green checkbox tells me that name's OK. And I'm going to create it in US East 2. And I'm going to create that like that. So the only thing you need to remember is the data center you created it in when you create the storage account. Because you want to match that up with your cluster, as I said. So that is creating. That will probably take, I would say, about 30 more seconds. So let's come back here. So this is where I go and create my Hadoop cluster, or my HDInsight cluster. And the way I do that is I say new. So this is the other thing. And when you first sign up for the account, when you come in here, this might be grayed out here. If it is, there'll be instructions for getting an invite code. It might take a day or two, but we are giving invite codes out to anybody that's interested right now. So you come in here, you say Data Services HDInsight Preview, and you say Quick Create. So I'm going to come up, we'll call this TechEd 999. I can pick a cluster size. When it says 4 data nodes, that means there's going to be one. This is a 5-machine cluster because there's one head node and then 4 data nodes or compute nodes. I could say all the way up to 32. And each of these nodes has 4 cores, and so you get quite a bit of computing power there. Eventually, we will start to enable people to do much bigger ones, 500, 1,000 if you need. But for now, this is the cluster sizes you can choose from. So I won't be greedy. I'll just stay with 4. Put a password in. And then if my account was created, there we go. And then I just click that. That's it. I just spun up a cluster, and that's off getting provisioned. The unfortunate thing is it takes like 15 minutes for Azure to provision that, so I can't really show this in the demo. But what I did ahead of time is I created another one, just like I showed you there. And it's called TechEd HDInsight Demo. So I'm going to go look at this cluster. This is kind of the home page in Azure for the cluster. Right now it's pretty limited, but we're going to put a bunch of work into here before we GA. But what you can do is you can monitor your cluster here, and then you can manage the cluster by clicking here. And what this does is this takes you to a place we call the HDInsight dashboard. So some of the things you can do on the dashboard is you can look at the job history. We have samples up here. I can monitor the cluster, so we have some monitoring here. Eventually it will all be in one place on Azure, but there's kind of 2 different places to monitor it now. I can remote desktop to the cluster if I need to. And then here's probably the most exciting screen. This is the interactive console. There's a couple of different ways I can interact with Hadoop here. One is through this JavaScript console. The other one is through the Hive console. Now I'm going to show the Hive console a bit later. So we'll just start with the JavaScript console here. And what I want to do is, there's a couple different things you can do with this. You can interact with the file system, and you can also launch MapReduce jobs. I'm just going to look at the file system real quick. If you do help, it shows you all the different commands. They're all pretty simple. ls is just shows me the layout of the directory. Now what I want to do is I want to make a directory. Let's call this my new directory. I forgot to delete it before the talk. So that would have created one if I hadn't had it before. Let's see if this. So you can actually push files up here. So I'm going to go get a file. I'll go get that app log file I showed you earlier. And then I'll put the destination in here. And that uploaded the file there. So this is really nice. This is in no way of something you would do in production, but it's really nice to kind of play with Hadoop, upload files, and download files, and kind of look at the directory layout. Now, so what's going on here? One thing, if you're familiar with Azure Blob Storage, it is a flat file system. There are no directories in Azure Blob Storage. And obviously, when I just showed you there are directories in HCFS. So what exactly is going on there? Well, to figure that out, I'm going to load a tool called Azure Storage Explorer. This is just kind of a graphical way to work with Azure, a lot like File Explorer. I'm going to go to the count that I'm using to back the cluster I created. And let's go look in here, which is where the file should be. I know that might be just a little hard to read, but here's the actual file here. And I'll try to bring up the properties for this. So if you notice here, oops, just highlight that first value there. This is the name of the file. So what we have done is, since Azure Blob Storage is flat, there's actually a kind of a heuristic that everybody uses, is they just put the directory names into the file name, and then they just use a slash. And so in this case, I am in my user directory, and then aconrad's my name, and then that's the new directory I created, and then there's the file there. So this is now sitting in blob storage. Now, ordinarily, like I said, there's a couple different ways to get data up here. Most people don't use the JavaScript console. It's just for kind of samples and fun. Now, a lot of people, this Azure Storage Explorer, and there's a couple of other competitor products. This one is free. And this is really nice. It's not really the type of thing that you would write like production jobs with, but it's really nice at uploading like multiple files and kind of browsing and cleaning up things. So one of the things I want to show is, so I showed a single app log file. The idea here is that I might have a whole bunch of app log files. And in fact, what my app does is I've written a little program that every night at midnight, it snaps off the log and it uploads it here. And so what I'm doing is just basically the first phase of kind of the pattern that you want to do with data management with Hadoop. What I'm doing is I'm going to, as soon as I'm done with the file, I'm going to upload it. And then every night I will upload the same file. Now, a couple of cool things happen here. First, as I told you, this storage lives independent of the cluster. So I can do this, and I don't have to spin up a cluster till I need to. Second, because the economics behind this is so affordable, that I can store a bunch of data up here that I have no idea what I'm going to use it for, but maybe in the future I figure that out. So it just basically becomes a dumping ground for my data, which is kind of a totally different way to look at enterprise-oriented data these days. So that was a quick demo there. We talked a little bit about this. So just the highlights. This is probably the most important slide in the whole deck. But the blob storage is inexpensive. We make it perform better than HDFS. It is something that you definitely will want to store stuff permanently in and not really worry about, filling it up and stuff. So I'll give you, this is a little, how does Hadoop know about blob storage? So as I said, we implement blob storage and we implement the interfaces that HDFS requires and we plug in. And then anytime you refer to a file when you're using HDInsight, we use this URI syntax that I have right here that begins with ASV. It's pretty easy to understand this. The first part is the container. So blob storage has containers. This is my account, and then this is the base URI for the blob storage in Azure. Then after that, you can put whatever path you want. The ASV here, it actually stands for Azure Storage Vault. This is the key that when we plug into Hadoop, we say anything that starts with ASV, we will take care of. And so anytime Hadoop sees this, they just pass it to our code, and then we get them the correct file. Now, the password or your key is stored on the cluster in something called site.config.xml. So there's two parts to the Hadoop world. One part, if you really want to be a Hadoop expert, there's hundreds of config files on the cluster that you can go play with and set a bunch of things. In HDInsight, we're trying to make it so you never have to do that. In this case, when I created the cluster and pointed it at the storage count, this entry was actually put up in my cluster for me. And so now I never have to take care of that. So now I want to talk a little bit about transferring data, and we've talked somewhat about this. So as I was talking about before, using the JavaScript console with hash put, it's kind of a fun little way to do things. For production data, you can do stuff like the tools I discussed. There's also something called AZ copy that's part of the Azure SDK. It's very similar to Xcopy, so it's kind of an industrial strength, production ready way of writing PowerShell scripts that copy files up to Azure and delete files and modify files. And so that is included, and it's being really widely used now. There's also Azure Blob Storage also has a complete set of REST APIs if you're interested in going that direction. We're also starting to see a lot of movement with upload and download tools, kind of third-party stuff that is optimized to get the data up to the cloud quickly. There's some tricks you can do with protocol and stuff that makes it a lot faster than the standard REST protocols. So you will start to see a lot of that. Here's just a quick example of AZ copy. It's not really that exciting, but I just want to show people that all you really have to know is you just have to understand the URI syntax for blob store, and then it's just like copying a file to any directory using like Xcopy. So let's actually dig into Hive a little bit and look at some real data. So I'm going to click over to the Hive console here. So Hive is a data warehousing application that comes with Hadoop and is by far the most popular part of Hadoop. The cool thing for people that aren't familiar with Hive is that anybody with a SQL background can become a Hive expert in like a day. Hive uses a query language called the Hive query language, and it's about 99% similar to SQL. So if you know SQL, you know Hive. Hive has tables. You create tables in a very similar manner to SQL. So if you know how to create tables in SQL, you can probably learn really quickly how to create them in Hive. There's a couple of key differences that I'm going to highlight, but really don't be scared by Hive. If you have a relational background, you can totally approach Hive, and you can be up and running in a matter of minutes. So what I want to do is, what I showed before is I have this container, and in that container I've created a directory called raw. And I have to do that using the file name trick. And then what I'm doing is nightly I'm uploading my app log files. So I want to talk a little bit more about what this file is. So my business, my fictional business, we have a number of mobile apps on all the different platforms. And what we do is every time a request comes into our service from our apps, we log the request. and we figure out how long it took. We figure out what platform is calling us. And then if you look on the far right where it says general or preferred, we actually keep track if you're one of our kind of elite customers versus someone that doesn't use our business a lot. So you can imagine there's lots of analysis that we might want to do on this. So in this case, for this demo, I'll be like the IT pro or the dev working for my company. Later I'm going to be the marketing person, but for now I'm just the dev. So I wrote this app, it logs this stuff. I don't really know what to do with it. I'm sure marketing has some ideas, so I'm just dumping these files up there nightly. So what I want to do is I need to do a couple of different things. I want to get some structure over this, and then I want to curate it a bit. So the first thing I do is I'm going to create a table. So here is the Hive create table script. Now, let's first talk about what's similar to SQL. The first thing is I just give it a table name, and I give it a schema. And then it's just create table. Now, the key difference is first, I see the word external here. So like I was saying, when you create a table in Hive, the data is not brought into any sort of storage. It stays in that file. It literally stays in that file there. And so when I say external, I'm telling Hive to point in an external file. Next thing is, as I talked about, the data can be in any format you want. There's a concept in Hadoop called SERDI. It stands for serialization and deserialization. And what it is it's a plug-in model where if you write something that knows how to read and write files in Java, it's this little Java component, then you can actually have any file format you want. For example, that HTML that I showed you before, somebody has written a SERDI for HTML, and you use that SERDI to load the HTML and make it look and put a table over the top of it. So in this case, I'm just going to use, there's a number of SERDIs that are just built in. The probably most widely used one is just comma delimited, new line terminated text files, and that's what I showed you my app logs are. And then finally, I have to tell Hive where the file is. And this is just that ASP path we showed before. Now, the key thing here is I'm not pointing at a file. I'm actually pointing at a directory. So I can create this table. I can start doing queries and analysis against it. And then I can continue just uploading text files into this directory. And as soon as they're uploaded, they become part of the table. So it's a lot simpler than even like BCP. You just have to do file copy. So I'm going to go ahead and run that. So one thing you'll learn about Hadoop is meant to be batch queries over huge amounts of data that may take minutes or days or hours. In this case, this query probably took about 2 seconds. But there is some infrastructure there. I'm not going to say the word slow. I'm not allowed to say slow, but it does take some time. And the reason for this is that there's a lot of heavy machinery there. And you think about it, the data is distributed. The system needs to build a plan to kind of coordinate all this work across multiple clusters or multiple data nodes. And so anytime you run small queries, now this is actually faster than I've seen in a long time, but it's still about a second. Now if you ran the equivalent thing in your relational database, it would come back in a fraction at a time. So one thing to understand about Hadoop is this is not meant to be like a relational database where you randomly grab rows and expect really high performance. This is meant for batching and scanning of files and processing large amounts of data. So we created that table. Let's go ahead. I have a couple of queries I'll run here, and you'll start to see what I'm talking about. So one of the differences, I told you it was 99% similar. One of the differences, if you want to limit your results, you actually use limit at the end of the query. So this is going to select the top 4 rows in the mobile app logs table. And as I told you, it sometimes takes a little bit of time. Okay, that was about 3 seconds, and there's the first 4 lines. And so what has this actually done? So this Hive gets the query analyzer is in Hive. It's gone out to that H catalog I told you about where the metadata is stored. And what it does is between the query statement and the metadata, it translates the query into a Java MapReduce program. And then that MapReduce program is written or ran over the top of my data, and that is what is returned. One thing to remember here is that it's always a scan. There's no indexes here at all, and I'll show you with my next query how that affects performance. But this is literally, the program runs in parallel, and you can get a lot of performance benefit there, but there is no indexes. So you would never ever use Hadoop for kind of random access of data, as I've said before. It really is just straight batch processing. So I'm going to run this query here, and this actually is going to apply a predicate. And then just limit the results at 10. This one will take a little bit longer, give me a little more chance to talk. But so Hive has all the standard relational operations that you would expect. You can order things, you can project, there's aggregates, you can group, there's predicates like I'm doing here. So anything, just about anything you can do in SQL, you can do in a Hadoop. The one thing is in Hive. The one thing is if you get a little farther down the road and you start to do more complicated queries, there are times where the query will get translated to multiple jobs. Either because Hive just doesn't have the right optimizations in place, or that's just the fastest way to do it. So this isn't, like I've been saying, this isn't like a relational query analyzer that goes out and just grabs the rows that you need. This translates literally to Java statements that are run over your data. So that came back. So that's pretty cool. So let's go back. So what I want to do, so as the first part of this, as the DBA, I've loaded all my data up into Blob Store. And now this is, there's a lot of data here, and it's still a little bit rough. It's not really ready for my marketing analyst. So what I'm going to do is I'm going to curate that a little bit. So to do this, and this is one more kind of difference with Hadoop. When you're working with Hive, what you want to do is you always want to create tables, and when you run queries, you want put that result into another table. Now, if you think about what we're doing there, what that actually does is I'm going to create this table here, and I'm going to run the query below, which selects all the rows for the month of November. Now, what is happening here is when I create the other table and I select into it, Hive is literally running the query, getting the results, and writing it into another file. And this is a file I can download or use for further queries. So the whole idea is every time you create a table, you're creating a set of files. And that's really how you want to manage your data there. Now, in the console, you can run a query and we'll return the results. But that's real transient, because what is happening there is we run the query, write it to a temp file, spit it out on the console, and then we delete the temp file. So the other thing to keep in mind here is there is no streaming of results. It always goes from one set of files, and it's always written to another set of files. And even when you use our OWC provider, it's doing the same thing. It's writing to a temp file, and then that temp file is being returned. So let's create this table. Just 1 second. So this is really similar to the table we created before. So that worked. So let's come here and run this query here. So this is going to take data out of my mobile app log table and put it into mobile app logs November. Now, the thing that's probably making everybody in the crowd cringe is that I'm using string functions to parse the date. But if you remember, one of the other points about big data is that big data has a wide variety of data types. The app logs I have are just text right now. There's no typing applied to them. And so Hive doesn't really have a datetime type right now. It just has types like number and string. And so in this case, I have to treat this like text. Now, if you're going to work with a wide variety of data sources in Hadoop, this just becomes a reality. You just have to deal with this. And you have to do things like is everybody cringing when they see the string function there? Or is this pretty standard? Anyway, You just have to get used to working and get used to working with a lot of kind of text functions. So let's go ahead and run that query. And this hopefully will just take a couple of seconds. So this is kind of my curate step. I've really simplified it a bit, but you do see in the projection I am changing the date a little bit. I'm just pulling out the date, not the time. And so you can think about in this process, what I'm doing is I'm refining the data. And this is with the Hadoop kind of standard pipeline. What you do is you load the data, and then you refine it, maybe several passes. And the whole point of the refining is getting it in a shape that you can use and a size you can use. So that's still thinking. So that finished there. OK. So now we're done refining our data. So let's hop back here real quick in the presentation. So now I'm all done. The dev Andy or the DBA Andy is all done. I've uploaded my data and I've refined it. Now I want to start sharing and consuming the results. Now this is only the beginning. We're going to put in a huge amount of investment at Microsoft on this. Obviously, this is a big deal for us, right? So if you look here, this is a few ways you can share and use the data right now. You can use Scoop, which is, as I was saying, a BCP utility that comes with Hadoop to load into SQL Server or SQL Azure. You can load into Excel using a tool called Data Explorer. I'm going to demo that in a second. You can put it into a different blob storage account. There's no reason you can't move it around up there. And in fact, moving blobs around actually within Azure is a very efficient, cost-effective thing to do. We also have an ODBC driver that is basically intended for kind of legacy BI apps. For example, this is how you hook up analysis services or reporting services. A lot of the Microsoft stuff will eventually move away from ODBC. Now, the reason for this is ODBC really isn't a batch query type environment. You can imagine if you run a query in Excel and you were using ODBC and the query took a day, you'd have to leave Excel open because the connection has to stay alive. Right now, this is kind of where we are, and this gives us a nice story for third-party products like Tableau and stuff like that, because everybody implements ODBC. But eventually, we are pushing everybody away from this and have a much more natural kind of issue the query, and then you could close down the app and you come back later and get the results. So I'm going to show just a quick. I got a little story here. So I am shifting to be the marketing guy, and I actually have one of my marketing coworkers sitting right here. And so I don't know if you guys have been around town, but they sell these hats. Has anybody seen this? Been offered a hat? Well, so he bought me this hat last night, and so I kind of think, marketing people are kind of fancy. Are there any marketing people in here? Okay, one. So for my marketing role, this is the marketing Andy. I'm going to put on the hat because marketing people are kind of fancy. They kind of like to go over the top. So, and what is the tool all marketing people love to use? There we go, Excel. So I'm going to bring up Excel. Now what I want to do is, now that Andy, the dev, has curated that app log data for me and got it in a size and shape that I can consume, Andy has come and told Marketing Andy that that file's ready to go. So to get at that file, I'm just going to create a new spreadsheet here. I'm going to click on Data Explorer. So Data Explorer is an app right now that's in preview, and it's a download for Excel. Eventually, it'll just be a native part of Excel. But what it is it's something that's really good for doing data discovery, and it understands an enormous amount of different data formats and everything. So it's really good at bringing data into Excel. So what I'm going to do is I'm going to go from other data sources. I'm going to say from Windows Azure HDInsight. And I got to remember my cluster name. TechEd HDInsight demo. So if I type that correctly. So this is going out and it's connecting to my cluster. But actually, to be more specific, it's not connecting to my cluster, it's connecting to the storage account associated with that cluster. Now what's cool here is, let's say when I was all done curating the data, I didn't want to pay for the cluster anymore. It's sitting up there idle, but I'm still paying a little bit for it. So I just decide I just want to tear that down. This will still be here, and Marketing Andy can still access this file from Excel just like the cluster was up. So what I'm going to do is I wrote those results out to this results directory. I didn't give it a file name, so Hive just decided the file was 0000_0. Normally you'd probably give a file name, a friendly file name. But what I'm going to do is I'm going to say drill down. And so this is imported like the first 50 rows. It's giving me a preview of the data. And what I can do with the preview of the data is I can try to interpret it and transform it and shape it in a way before I import it into Excel. So what I'm going to do is I know that this is delimited by column, but Data Explorer doesn't know that. So I need to tell it that first. So I'm going to say split the columns by delimiter. I feel really silly wearing this hat, but we'll keep running with it. I don't want this. It's just URI. I know I'm not interested in that. I'm a marketing person. I don't even know what this is, so I'm just going to remove this. And then the one thing I want to do is, as I talked about, remember we were storing all this as text. So Excel doesn't know right now what the types are. So instead of being text, I actually want to make this a date. And then instead of being text for this number, I actually know it's a number. So what I've done is I've actually built up, and you can look at this, or it's interesting. You don't have to know about it, but this has built up a list of instructions. And what's going to happen is when I actually load this, Data Explorer is going to go out and start grabbing those rows off my cluster, and it's going to perform this transformation on the data and then load it in. Now, I only have 4 steps here. This could be 50 steps. It could be 100 steps. But what Data Explorer what's really nice here is it provides you kind of a graphical experience to build up how you want the data to look. I've done some fairly simple things. There's actually some very complicated expressions you can do. And then it will play this back as it pulls the data in. So I am all done, so I'm going to say done. And so it's going out, it's contacting my cluster, it's starting to pull rows in, and there it's all done. So it pulled in 1,000 rows, provided the transformation I want, and now this data is sitting in Excel. Now the only other thing I want to do is I want to say load to the data model. And what this is this will actually put it into the Power Pivot data model, which is part of Excel natively now in the newest release of Excel. So now I can use Power View, Power Pivot, GeoFlow, some of the stuff that we've been demoing all week. Now this is pretty crude right now. In a few months, this is going to be even a better experience because we're building the capability in the HDInsight. When Data Explorer connects to the storage for my cluster, Data Explorer will actually be able to figure out what the schema was. So if you remember, I created a schema for that output table, and it went into that file. And we're teaching Data Explorer how to look at the schema. So those 3 steps I did, having to split it and having to change the data type, I'm not going to have to do in a few months. So this experience is just going to keep getting better. One other thing we're thinking about is being able to push down. So example, Data Explorer allows you to write a predicate as the results come in. And we envision in the future sometime soon that we may be able to teach Data Explorer to actually issue a Hive query, push it to my cluster, and then consume the results from there. So that's the end of the marketing part. I'm my marketing person. I have my Excel. I'm all happy now. So I'm going to take the hat off. But so I kind of want to summarize. There's many things you can do with Hadoop, but kind of the most basic way people should get into it at this point is when you do just basic. It's just like the traditional ETL you do, where you, let's click to the next screen here. Think about extract as pulling stuff out of other data sources and putting it in Azure. Think about transform as writing Hive and Pig queries and map reduce jobs. And then think about load as pulling it into Excel or putting it into SQL or putting it into reporting services. So it's very, very similar to any ETL that you may have done in the past. The one key is that the transform, you are harnessing the power of Hadoop. So if you have large, complicated data, the transform is much different, but the general pattern is very similar. So we offer a number of things in programming HDInsight. The top there is, these are existing Apache apps. I've talked a little bit about Hive and Pig. There's just a bunch of other names. I'm not really going to go into them, but there are a bunch of different ways to program against Hadoop. Now, we actually offer a way in C# and F# to do MapReduce. That's part of our SDK. You need to go look for the HDInsight SDK. All the .NET, the JavaScript, and the stuff at the bottom is all completely open source. We take takebacks and everything on this. And so we've also written a link to Hive translator for people who are familiar with Link. And then we have a whole set of .NET management clients. Now, on top of this, we have a way in JavaScript using Node.js and in PowerShell. And this stuff ships as part of Azure One SDK to do kind of remote cluster creation, job submission. So people are already writing jobs where in PowerShell, they fire up a cluster, they copy a bunch of data, run a job, tear down the cluster, and then pull down the results. So this is all ongoing work. And as I said, this is completely open source. And we're taking contributions. We actually would love it if some people in the community would take over some of these projects if they wanted to. But really, we're trying to build a whole ecosystem of kind of .NET stuff, similar to what has built up in the Java community. And here's a little bit of information. I'll leave this slide up at the end, but this is where the SDK is, where the sources are. There's also NuGet packages. If you search on Hadoop in Visual Studio, you can get our packages. And then like I was saying, we're part of the Azure One SDK. So that's kind of the end of the presentation. In summary, Hadoop is all about kind of big data processing and really taking care of the data when it's big and complex and getting it in a form where you can load it into your more traditional tools. There's a lot to it, but I hope I kind of demonstrated that you can dive in and start playing with it very quickly. And that the way we've implemented it with Azure Blob Storage actually makes data movement and management very, very simple. So that's it. If I have any questions, I can take a few minutes on those. Anything? Everybody tired? Yeah, go ahead. Excuse me? HDInsight is a preview. It's preview. So when do you believe that it will actually I think it's safe to say before the end of the calendar year. So we do have a lot of people, to some extent preview just means it's half the price right now that it will be at GA. And so we do have a lot of people already doing production-based stuff on it. So you should try it out. Any other questions? Yeah.
Demo is on Keynote.
Yeah. The Blue Yonder Airlines?
Yeah, with the map.
Oh, GeoFlow, yeah.
That data was all prepared beforehand.
What?
It was Data Explorer, but I'm guessing all the data was already in an external table.
Oh, yeah, yeah. So there's one part to this demo that I didn't show today. Has everybody seen GeoFlow? Okay. So the last part of the demo is that we would load then the data into GeoFlow and do kind of some visualization on it. The idea there is all the data that we showed in GeoFlow was loaded from Hadoop via Data Explorer.
Hadoop or from the blob storage?
Excuse me. It connects to the blob storage for the cluster, right? So, yeah. Any other questions? Okay, if people, I'll hang around for a few minutes if there are any other questions, but thank you.